Hi girls, I wanted to walk through some of the problems that you had questions on the practice test on forces and applications of Newton's second law. So if you, the screen right now I have showing the first problem. This was similar to a problem that we practiced today in class, and you can see in this case, you know the acceleration of the whole system is 2 meters per second squared. As in almost every problem you do which involves forces, the first thing you should do is draw a free body diagram. In this case, we're being asked to find the tension in the rope at point X. So I suggest that you pick any one of these masses that's connected to point X. I happen to pick the 4 kilogram box. So I drew the two forces that are acting in the horizontal direction. These are the ones that are going to contribute to the acceleration of the system. And then the next step, step 2, is to write Newton's second law in terms of the forces that you're given. So Newton's second law says that the sum of the forces is equal to the mass times the acceleration of the body. In the case of the 4 kilogram box, we've got a pulling force and a tension force that are acting in opposite directions. So the net sum of the forces is the pull minus tension, and that's equal to the mass of the box times the acceleration, which we've been given. Every box in this system accelerates at 2 meters per second squared. Putting in what we know, this Newton's second law equation simplifies to the pulling force minus the tension force equals 8 newtons. The problem is we still have two unknowns. We don't know what that pulling force is. So step 3 is to go back and look at this scenario as a system of 3 different boxes, all connected together, that are accelerating at 2 meters per second squared. In the absence of friction, we're told it's a frictionless surface. The pulling force is what's causing the acceleration of 2 meters per second squared. So I can solve for the pulling force by looking at the net force of the whole system. The net force of this whole system of 3 boxes is the pulling force equals the mass of the system times the acceleration. Solving for that, I can solve for the pulling force as 16 newtons. So now I can just go back to my net force equation that I looked at in step 2, where the pulling force minus the tension is equal to 8 newtons. And solving for the tension, I get that the tension is 8 newtons. So that's question 1. Question 2 is a friction problem where you've got this carton of apples and you know that it's accelerating at 1.8 meters per second squared, and it has 120 Newton force acting on it, and you're supposed to be finding the coefficient of friction. Well, again, always start with a free body diagram. So I've drawn the weight force and the normal force, which in this case are equal to each other because this is a level flat surface and all the forces are acting horizontally. And then you've got the 120 Newton pull force and the friction force impeding that. I know that the 120 newtons is a bigger force because I have a net acceleration to the right. The next thing you do is you write Newton's second law equation in the direction of the acceleration. So that's the x direction. So the sum of the forces acting horizontally in the x direction are the 120 Newton pull minus the force of friction, and that's equal to the mass of the carton times the acceleration. I plugged everything in and I solved for the friction force, and I found the friction force is 75 newtons. Now that I know that, step 3 is just to solve for the coefficient of friction. Well, I know that the friction force is equal to mu times the normal force. So the friction coefficient mu is the ratio of those two forces. And I know what both of them are. I know that the normal force is equal to the weight in this case because this is a flat surface, as I mentioned. So the weight of the carton is its mass times the acceleration due to gravity. Solving that, I get 0.31. Thank you. That's the first two problems. I will talk about the next two problems in a second video.